Okay, welcome back. In this tutorial, we're going to cover orthographic projection. So what have we done so far? We've done some sketching. We've done a lot of single view drawings in AutoCAD, and we did that to teach geometry creation, modified tools, use of layers. It's a little more simple. And now that we've got a good grasp on those fundamentals, we want to go ahead and move forward to more practical parts, which are 3-view parts. Complex parts that have internal features such as holes, parts that are 3D, not what we would call 2.5 dimensional, just they say a flat plate with a series of holes in them, and parts that have angled faces. So this is the most important slide in this entire presentation. This is the glass box theory. And what the glass box theory tells us is that in order to get an orthographic drawing, you need to project all 3 views to a invisible glass box. So if we look right here, we see a square, and that square is back here, clearly at a different depth than this L shape here. But glass box theory tells us that they need to be on the same plane. So this face out here is a plane. And then the same thing here, we've got 3 different heights, but here they all show the same. And that's because we can't see depth in a 2-dimensional drawing. The glass box theory then lets us work between the views to determine what we see. So here again, we have an L shape here, an L shape here, and then this rectangle is the arc that we see over here. And we can see that with our top, front, and right side views over here. Gives us real shape and size without distortions, and it gives you the ability to visualize the part in 3 dimensions. So alignment of views and view order matters. So here we see our front view. Everything is hinged off of our front view, and we have our top view, our right side view, and so on and so forth. So the question then becomes, do we need all 6 of these views? And the answer is no. We use the minimal amount of views that we need to describe an object. So we have a brick here, and we can see that we have 2 dimensions. We have our height is displayed in the front view, and the width is displayed in the front view, but we don't know how deep it is. And depth is shown in the side view, and depth is also shown in the top view. So our standard views are top, front, and right side. And we need to talk then about views and what dimensions they have. So each view shares 1 dimension with another view. So what does that mean? Well, it means here we see height is expressed in the front view, and we also see height expressed in the side view, but we do not see height expressed in the top view. In the top view, we see depth, and we also see that depth in the side view, but we do not see depth in the front view. So that's something to think about when we're working through these problems. So of these views, which ones do we typically need? We typically need front, top, and right side. Next most important thing is the miter line. The miter line is a 45-degree angled line that originates from the upper right-hand corner of the front view, which would be here. That projects up to here. And this allows us to transfer dimensions between the 3 views using projection lines. So if there is no actual upper right-hand corner, this part doesn't have one, we would use what we call the apparent intersection. And that would be the uppermost and the furthest most right point. This corner here is the furthermost right, but it is not the uppermost. This point here is the uppermost, but not the furthest right. So that would be here, we would have the furthest upper right-hand corner of the part. So if we have a part that does not have a hard intersection like that, we need to make sure that we add that in there where it needs to go, or it's going to throw off all our dimensions between our views. So what about internal shapes? We've got an engine here that's got a lot of internal features. Here we see holes in the front view. How do we express the holes in the top and the side view? And the answer to that question is with hidden lines. So if we back up a step, we see here we've got an AutoCAD drawing of our brick with what we can see. And if we go to the next slide, we can see that we've added in projection lines from all of the holes and hidden lines that show internal features of that brick. So again, object lines are edges that can be seen. Hidden lines are edges that exist behind other surfaces. They exist, but they can't be seen, and they have to be shown as then hidden lines. So steps to creating a multi-view. I'm going to go through this relatively quickly because I am going to cover this in AutoCAD, which I think it will make a little more sense. In this case, for our first, we're going to draw the top view. Now, you don't always have to draw the top view. I recommend that you draw the view that shows the shape the best. Create projection lines from the top view down to the front view, draw that and trim as needed. Then we're going to add our miter line in, and we are going to then project over and go draw the side view and finish up our 3-view drawing. So for this example, we would draw the top view. And again, we don't know if this is a stair step, if this is shorter, this is taller, and this is the tallest, or if it's vice versa, or if this is a shoulder that sticks up, or a groove, a notch that is cut into the material. We have no idea because in the top view we don't see height. So now we're going to look at our front view, start the process of drawing it, trim off everything, and now that we see indeed this is a notch, then our next step will be to draw our projection lines, which is our miter line here and our projection lines over to the miter line and down, over and down, over from the front view to the side view, drawing our hidden lines, and then we're done. Now, view spacing is important. You want to have equal view spacing between your front and top view and your front and your side view. And the way that we do that is this distance is typically the depth of the part. When we draw our miter line from the upper right hand corner at 45 degrees, that does ensure that our spacing is the same. So please make sure that the space between the views is the depth of the part. So what we're going to do now is use this example. We're going to move over into AutoCAD and we are going to draw this part.